Okay, so for number 1, the first thing I did is I moved this to the front of the log, became the coefficient, so right here. And the second thing I did was I changed this to a fraction in reduced form. So 0.216, and I used the fraction key on the calculator, became this. Okay, so this log means 3/5 to what power, because this is what the log equals, this exponent up here, equals 27 over 125. So this here in the box happens to be a 3. So we have 4 times 3 equals 12 as the answer. For number 2, what I did is I took each exponent, this one, and I put it as a coefficient of its respective log, like here and here. And so that's what you have right here. Okay? And then just a reminder, log base 3 of 243, this part right here means this. We're looking for this value right here. Let's simplify. So I know that log base 4 of 4 is 1 because 4 to the first power is 4. So this is 1. So I'm left with x minus 2. And then right here, 3 to what power gives you 243, and the answer is 5. 3 to the 5th power. So that's going to be 2 times 5. So then that's x minus 2 plus 10. So that's x plus 8 as your final answer. Okay, so number 3, I put the exponent here as a coefficient of that log, so it looks like this. And this decimal, again, I took the fraction key on the calculator and so it gives it to me reduced. So this decimal equals this as a fraction. So I think it's easier to see how to find the answer to this log. So 8 to what power gives you 1 over 64? Well, I know that 8 squared is 64, so I want 1 over 64, so then that means the exponent has to be negative 2. So in this box here is negative 2. So then that means that this is going to be x times negative 2, which is negative 2x. Okay, so first thing I did is for number 4, is I took this exponent and put it down here as a coefficient of the log. And so you have that right here on the right side of the equation. Now log 10 is 1 because the base is 10. So 10 to the first power gives you 10. So this is 1. So here I have 2x plus 1. And this log right here is 2 because 3 squared is equal to 9. So I'm going to put plus 2. Combine any like terms, so I've got 2x plus 3. And that's the answer. Okay, so for number 5, you're solving for x. X is in the exponent, so you've got to change it to log form. So that gives you log base 5 of 50 is x. So because we don't have a base 5 in our calculator, we change it to log 50 over log 5, or we could write natural log of 50 over natural log of 5. And so that's going to be approximately equal to 2.43 after you put it in the calculator. We're going to change 6 to log. So we get log base 6 of 45 equals the exponent. We move the 2 over. So x equals negative 2 plus log 45 over log 6 because we changed the base. Put this into the calculator. And we get approximately 0.125. So we do change it to log form, so log base 20 of 15 equals the exponent. So then we're going to subtract 3. So it's going to be log base 20 of 15 minus 3 equals 2x. We divide by 2. And so x equals, I can write it as, I could put the negative 3 first. So negative 3 plus ln 15 over ln 20 all over 2. So you could put it into your calculator just like you see it. Negative 3 plus ln 15 divided by ln 2 equals, get that, that way you make sure you get all of that in the numerator, and then you divide by 2. And you get approximately a negative 1.048. Okay, so for number 8, it's log base 3 of 150 equals 5x plus 1. So we subtract 1. And so that gives me 5x equals negative 1 plus ln 150 over ln 3. And then we divide by 5. And again, you put this into the calculator. Just make sure you press, after you do this part, you press equal, and then you divide by 5. Okay? So you get 0.712 as an answer. Okay, so for number 1, it's 6/6 of 2.0736 to the 5th. So the exponent becomes a coefficient of the log. So here it is. And I put this into a calculator using the fraction key, and it gave me this as a fraction. Okay? And the nice thing about this is that I can see that 6/5 to the 4th power gives me this fraction right here. I just tried different numbers, and I tried 6 to the 3rd, 6 to the 4th, and it worked. And I tried it with 5. 5 to the 4th is 625. That worked, so that was, that told me that was the answer. And so let me just change this. So this would be 5 times 4, because the log is equal to 4. The answer is 20. Alright, so for number 2, we can use the difference of two logs is the same as the log of the quotient. So we combine these two logs as log base 2 of 3.2 divided by 0.025. And that, when you put it into a calculator, you get 128. So what this means is 2 to what power gives you 128? And the answer would be 7. So this problem equals 7. So the first step is to bring the exponents to the bottom as coefficients of the logs, of their respective logs. And so I end up with this line right here. This is 1, and this is going to be 4, because 3 to the 4th power equals 81. So I give these, cross this out. This is 1, so that gives me 2x minus 1. And then this is 4, so 2 times 4 is 8. And so that gives me 2x plus 7 as my answer. Okay, so the first step is I brought this exponent as a coefficient of its log right here. And then now I'm going to simplify this and this. So log base 5 of 125 is 3, because 5 to the 3rd is 125. So this is 3. And then this is 1, because 10 to the 1st power is 10. So this is 1. So that gives me times 1. And so that's it. So for number 5, we change it to log form. Log base 7 of 30 is 2x divided by 2. And then because our calculators do not have a base 7, we have to change the base. Now I chose natural log. You could have put log and log here, but this is fine too. Put this into a calculator and you get approximately 0.874. Okay, so you change it to log form, and so it's log base 5 of 20 equals the exponent 2x minus 1. So we're going to add 1. Because we added 1 here, so we got rid of that negative 1. Now we're going to divide everything by 2. So when you put it in the calculator, you're going to put 1 plus natural log of 20 over natural log of 5, and then put equal, and then you put divided by 2. So that gives you approximately equal to 1.431. Okay, so you change it to log form. Log base 2 of 215 equals the exponent. Notice I wrote the 0.5 as a fraction. You don't have to, but you could, that's okay. We're subtracting 7 from both sides, so we end up with negative 7, because we're subtracting 7. Log base 2 of 215 equals 1/2 x. So to leave x by itself, we're going to multiply both sides by 2. Right here, and this cancels the 2's right there. So then you put this into a calculator. You could do this part first if you'd like, and then double it, or you can just distribute. It's up to you. Okay, I'll put it in like this. ln 215 over ln 2. So you're going to do negative 7 plus ln 215 divided by ln 2 equals, and then whatever that gives you, you do times 2. Okay, and that's going to give you approximately 1.496. Okay, so for number 8, change it to log. Notice I did not put a base because it's 10, so it's a common log. So I just put log 15 equals the exponent. So now I'm going to add 3. And then divide by 3. Okay, so then you would just put it into your calculator. 3 plus log 15 equals, and then you divide by 3. Okay, so make sure you hit equal after you put log 15. So 3 plus log 15 on your calculator equals divided by 3, so you get x is approximately equal to 1.392.